For other videos or problems like this for Intro to Stat Methods for Business, you can go to Sarai Studies, link is in the description box below. Let's say that you have a data set, and this data set contains 3 x variables, so x1, x2, x3, and then the y variable. And if we plot this data set, let's say that it's not quadratic, because if it was quadratic, then we would do the quadratic model. Instead, let's say you have a data set that kind of looks like this. It's neither quadratic nor is it linear. And so we know that with using the linear regression model, it is best to use it on linear data, and this is not really linear data. So what can we do? Well, we can make it linear data by transforming either the x or the y values, but then the big question is, how do I know what to transform? To determine whether to transform the x values or the y values, we look at every x value and the y values residuals. Let's say that your residuals look like this. Here, this is random. And then this one looks like this. And then your overall y residual looks like this. We know that a good residual plot is random like these. But if a residual plot has a linear relationship or any pattern, then it's not good. And so what we do is we transform the third variable. That means that if we have a data set x1, x2, and x3, and then y, we're going to make a new column called x3 new, and then we're just going to take the first value and transform it. Now, how do we transform it? Well, we have two methods. Either we use the logarithmic method or the square root method. As to how to know which one to use, we'll get to that in another video, but this is really answering the question of what are we even transforming in the first place? In this case, it would be the third x variable. Now, let's say you have the residual for x1 looking like this, the residual for x2 looking like this, residual for x3 looking like this, and then you have the residual for the y's looking like this. So clearly I can see that for the y, there's a pattern in the residuals, and that's bad. We don't like that. And so what we're going to do is we're going to transform the y values. Now let's say we have our residual for x1 looking like this, our residual for x2 looking like this, our residual for x3 looking like this, just random, and then this one also looks like this. This is good and this is good because it's random, but this is not good because I can clearly see there's some sort of pattern here along with this one. So then when you have two that have a pattern, what do you do? Which one do you transform first? Always transform the y values. Now, why do we change the y value and not the x squared values? And hopefully this little story makes sense for you. So let's say this is the overall class grade, final grade, and this is one student's final grade. So let's say the overall class got a 90, and then this one student got a 30. So the question is, who's the problem? Is the problem the teacher or the student? Because this overall class grade really represents the performance of the teacher. So if the whole class did 90, did pretty well, and this one student did 30, then that must mean that the student is the problem. The student is going to be the one who needs to transform. They need to change. They need to change their study habits or something, because everybody else in the class did pretty well so that the overall grade was good. But let's say that the overall grade was a 40 and this student still, got a 30. In this case, more likely than not, the problem is now the teacher, because if the whole class is overall doing bad, not just this student, then we should probably transform the teacher. We should change the teacher. We should replace that teacher first. And when we replace that teacher, if this student is still doing bad, then we can transform that student. But sometimes we'll replace the teacher and this student will do good, and so no need for transforming. In other words, think of this as your y, and in this case, our x squared. So here we see that our y is not doing good, and nor is our x doing good. Our teacher's not doing good, nor is our student doing good. But who are we transforming first? The teacher, because if the overall grade is bad, then if we transform the overall, then that might fix this student's grade. So if we transform y somehow, some way, and it's starting to look a little bit like this, and then it makes x squared look like this, then great. So we transform the overall and it fixed this one too, so no need for more transformation. But what if it didn't transform the x? Like the y looks good now, it's random just like these, but the x is still a problem. In other words, the student is still a problem, then we transform the student. Additionally, until we transform and transform until all the residual plots look random and have no pattern. If you have a situation where you have a y that's not good and you have one of the x variables, always transform y first, and then if this is still looking like this, then transform the x as well.